So we're trying to solve this. This is where trig gets more difficult, solving trig equations. So we're trying to find all the values of theta for which this is true in that range of theta. Because there's going to be more than one answer that lets that happen because we know because you know trig repeats, it kind of oscillates, it's got a period to it. So there's going to be a few different answers that let this happen. So some of you will spot that we've actually got a transformation. We've basically got a sine theta graph that's been moved to the left. Rather than worry about what this looks like though, the easy way is to transform the limits. So we're going to transform these limits and then solve this trig equation. So step one. So transform our limits. So our limits are for theta, but we're solving theta plus 30. So we're going to write theta plus 30 as our new kind of value. We're going to add 30 to both our limits. So we get 390 and minus 330. So that's the range of values we're going to be solving for our value. Next bit, we're going to try and find our principal value, which is the first value. So to find our principal value, we're basically going to solve this and find the first value that works. So inverse sine root 3 over 2 will give us theta plus 30, which is the thing we're trying to solve. So that gives us 60 degrees. So that's our principal value. So now we're going to sketch sine between those between these limits and find all the corresponding values to 60. So step 3, sketch and find right. So similar to what we were doing at the end of last week, finding equivalent trig values. So if we do a sketch. We're going up to 390, so we need a little bit more than that. So another 30 degrees worth or something like that. We're only going down to 330, so we can get rid of a bit of that. Cool, so our first value is 60 degrees. So find 60, which is about, there's 90, so 60 can be over here. So as I was saying, 60 is our first value. So we want all the equivalent values. There might be one here. Probably two there, we'll check those out. Right, so our first value yet, we set 60. So we're going to measure the rest of the angles from where it crosses the axis. So this one's going to be 60 less than 180. This one's going to be 60 more than 360. 60 less, and then 60 more. So all of my angles then, we can say 60. We've got 180 take 60, which is going to be 120. We've got 360 plus 60, which is going to be 420. But that's outside of our limits, so we won't bother with that. Two more here, so this is going to be 180 take 60, which is going to be minus 240. And then minus 360 plus 60, which would be minus 300. So, 4 values, and those values were all values of theta plus 30. Because we never changed anything, we solved it for theta plus 30. So we want to try and find theta, so we need to subtract 30 from each of those. So we're going to get 30, 90, minus 270, and minus 330. We can check those, we can put those back into here, see if it does equal root 3 over 2, and then test that we've done it. Cool, so that's what we're going to be doing this week. Solving some trig, transforming limits, sketching and finding all the equivalent values. It's not hard once you've tried it a few times, but it is a bit new and a bit different. Cool, right, let's try a tan one. So trying to solve this one, so again, we've got a transformation, it's a stretch, we're not going to worry too much about that though. We're just going to transform the limits. So step 1, transform the limits. So our limits for 2x, we need to double those, so we're going to get 360 and minus 360. Step 2 was find the principal value. So solve this, so tan to the minus 1, 5 equals 2x, so 2x equals, if you do it on the calculator, I think it's 78.7. So that's our principal value. So now we're going to sketch and find all the equivalent values. So, minus 180 to 180. So tan looks like this. But we stretched it, so we're going up to 360. And minus 360. So 180. 360. Cool. And like before, find our principal value on here. So 78. So this is 90. So that's probably about 78 there. So it should be 1, 2, 3 other solutions. And we'll measure 78.7 from where it crosses again. So it's going to be the same each time on these. So our values then, so 2x equals, first value 78.7, next value is going to be 180 plus 78.7, so we will get 258.7. We're then going to get minus 180 plus 78.7, so it's going to be minus 101.3. And this one, minus 360 plus 78.7, is going to be minus 281.3. Cool, last step, divide those by 2 to get x. So we get x is 39.35, 129.35, minus 50.65, and minus 140.65. So 4 solutions. Again, if you put those back into here, we should prove that they roughly equal 5, so you can check your answers. And it's always worth double checking that you're inside the limits. So each of those values is between minus 180 and 180. Cool, right, let's try a couple more of these. These are still the pretty easy ones, but what next? So let's do on the sign. Cool, so try and solve this one in the interval. So if you want to pause it and try it, it's the same as we were doing before. I'll go through it now. So step 1. Actually this time we've got x, we don't need to find the limits. So the limits are the same. The limits don't change because we're solving sine x and our limits are already given for x. So step 2 is the principal value. So this time we need to rearrange this a bit. So 5 sine x equals minus 2. So sine x is minus 2 over 5. So our principal value is going to be sine to the minus 1 minus 2 over 5. Which gives us minus 23.6. Okay, which is interesting because this value is outside of our range. So we can use this to find some values that are in our range, but that itself will not be one of our answers. So next step is the same, sketch it. So we've got a sine graph from 0 to 360. So there's sine. And we want to sketch a bit more just so we know what's going on with this minus value. So again, 90, minus 90 is about here, so minus 23 is somewhere here. So that value is 23.6 away from 0 in the negative direction. So we're going to get two equivalent values here and here, and they're both 23.6 degrees away from where we cross. So this is going to be 23.6 that way, and this is going to be 23.6 that way. So our solutions, x, is going to be 180 plus 23.6, which will be 203.6, and 360 take 23.6, which will be 336.4 degrees. So two solutions this time. This one isn't a solution because it's outside of the range, but we've used it to find those further on solutions. Right, so we'll try one more of these ones with two transformations this time. Cool, right, so if you want to pause it and try it, you can. So again, step one is going to be limits for this one. So we've got limits for theta. We're not solving that, we're solving 2 theta plus 30. So we need to times each of those limits by 2 and then add 30. So you just do what it says. 0 times 2 is 0, plus 30 gives us a lower limit of 30. And the upper limit times that by 2 to get 360, plus 30 is going to be 390. So that's my new range of limits. Step 2, principal value. So I'm going to inverse cos a half, which will give me this time 60 degrees. So 60 is what I'm looking for in this interval. So the limits are from from 30 to 390. So let's just sketch the whole of cos. An extra little bit. And my first value was 60. So let's put that in. So this time we're measuring from the peak of our wave. So it looks like we're only going to get one other solution for this, which will be there. There might be one here. We'll check, although if that's 60 away from the peak, this limit goes up to 390. Then we're not going to find that. So not going to get that one. So just one other value for this. So if that one's 60 away from 0, this one's going to be 60 away from 0 here. So this value is going to be 300. So we can say 2 theta plus 30 equals 60. And it also equals 300. So to undo this, simple, trying to undo this, get theta on its own. So we take 30 first. So 2 theta is 30 and 270. So theta is going to be 15 and 135, what we divided by 2. Cool. Alright, that's it for today. Make sure you're happy with this because every other thing we do this week is going to build on all of that. So go through, practice a couple times. But yeah, cool.